Welcome everyone. Welcome to the DICV Public High School YouTube channel. I am Parthiv Shu, an assistant teacher in the Department of Chemistry, and today we are going to start the first chapter in class 11 chemistry, that is some basic concepts of chemistry. Now in this chapter, as the name says, some basic concepts, we are going to study about very basic concepts about chemistry like mole concept, stoichiometry, about laws of various conservation laws like laws of conservation of mass, laws of multiple proportion, etc., that are very fundamental to the chemistry. Now before starting, first we are starting this chapter. First we are going to first I want to tell you that in this chapter we will start from the very basics. Like first we are going to start about what is matter. We know all that anything that occupies mass and that has mass and occupies some space is known as matter. And what is non-matter? Anything that does not occupy mass or does not have mass or does not is not constitute of particles is called a non-matter, like human feelings, like light, etc., electric current, etc. And matter are, for example, O2, N2, molecules, gases, various substances, they are matter. Now matter can be classified according to the physical and chemical. That is, first we will discuss about the physical classification of matter. Matter can be classified into 5 categories. That is, first is the solid, second the liquid, third the gas, fourth is the plasma, and last is the Bose-Einstein condensate. In short, we write it as BEC. Now let us discuss some properties of these states. First is the solid state. In solid state, solids have fixed shape and size. Okay, whereas liquids have no fixed shape and size, whereas gases also have no fixed shape and size. Now volume. Solids have a fixed volume, liquids also have a fixed volume, not fixed volume, they take up the shape of the container in which they are poured in, and gases not have any fixed volume. Third is the intermolecular force of attraction. Solids have very strong intermolecular forces of attraction, whereas liquids have a little bit weak intermolecular forces of attraction, whereas gases have very negligible intermolecular forces of attraction. Next we come to the compressibility. Solids are non-compressible, they cannot be compressed, whereas liquids are slightly compressible but not to that high extent compressible, just like gases, which are very highly compressible. Next we come to the melting point. Melting point of solid is above room temperature. This is in solid state. Now today it is in solid state because its melting point is above this room temperature. That's why it is in solid state. For liquids, melting point is less than room temperature, that's why it melts and forms liquid. Gases also have melting point less than room temperature. Coming to boiling point, solids have boiling point above room temperature, liquids also have boiling point above room temperature, but gases don't have boiling point above room temperature, they have boiling point below room temperature. Now these are the facts about the 3 states. Next we come to the plasma state. What is a plasma state? Plasma state exists at extremely high temperature, and it is formed when gases are ionized at high temperature. Suppose in a container we have a bunch of gas molecules. These are the gas molecules having the minimum or negligible intermolecular forces of attraction. Now if these gas molecules are ionized, then if these gas molecules are ionized, now we know that each atom consists of the nucleus and the electrons are revolving around the nucleus. If these gas molecules are ionized, then we are left with this nucleus, that is the positively charged portion, and the electrons outside. Now these positively charged species, these are the gaseous ions formed after ionization, after removal of electrons, and this is the plasma state, and this it occurs at very high temperature. This is formed at very high temperature, and when this plasma state is deionized, it forms back the gaseous state. So this was all about the plasma state. Next we come to the Bose-Einstein condensate state. It is created at temperatures very close to absolute zero, that is 0 Kelvin or minus 273.15 degrees Celsius. Typically only a few billionths of a degree above absolute zero. At such low temperature, the atoms lose almost all of the thermal energy, and each of the atoms, they start to behave in a unique way. So this is all about Bose-Einstein condensate. Now next we are going to discuss about the chemical classification of matter. In the chemical classification of matter, we have 2 categories. That is, one is the pure substance and another is a mixture. So matter can be classified chemically into two categories, that is the pure substance, another is the mixture. What are pure substances? Pure substances are substances substances that consists of only one type of compound or one type of element. So pure substances can further be classified into two categories, that is elements and compounds. Now what are elements? Elements are pure substances which consist of only one type of atoms, not just one atom only, but one type of atoms. For example, S 8, it's an element. It may look like a molecule, but it's an element because it consists of only one type of atoms. Similarly, O2 is an element. It's a molecule, but since it consists of only one type of atom, it's an element. Similarly, helium, it's an element. But what are compounds? Compounds are those pure substances in which the two components or two elements are combined together in a fixed ratio by mass. For example, NaCl, it's a compound. And also in this NaCl, since why it is a pure substance, because in this NaCl no other impurities or no other elements are present. In this NaCl only sodium and chloride are combined together in a fixed ratio by mass. Now the one important characteristic feature of pure substance is that pure substance, out of this pure substances, elements cannot be physically separated, but compounds can be separated chemically into two, into their constituents. Next we come to mixtures. Mixtures are impure, not pure substances. They are impure substances consisting of two or more compounds. And mixtures, we can classify mixtures into two categories, that is the homogeneous mixture and heterogeneous mixture. In homogeneous mixture, the components are separated, are mixed uniformly throughout the mixture, whereas in a heterogeneous mixture, the components are mixed non-uniformly. Example of an homogeneous mixture is salt in water or sugar in water, in which the two components, that is the solute salt or sugar and the solvent, that is water, is mixed in a throughout uniformly, whereas in the heterogeneous mixture is a mixture in which the two components are mixed non-uniformly. For example, sand in water, after some time, if we see, the sand settles down at the bottom of the water. So this was all about today's lecture. In the next lecture, we are going to discuss about what are atoms, molecules, ions, and about the Dalton's atomic theory, and then we will move on to the various laws of chemical combination. Thank you everyone for your patient hearing. All the best.